we can move on to the next presenter, please, Jonathan. So next up we have Emmanuel Mathot from Terradue.
Hello, everyone. Thank you for being here today. I'm glad to present you the culmination of more than a year of development using cloud-native technologies for the Disaster Charter Initiative. The mission of the International Charter of Space and Major Disasters is to facilitate the acquisition and the delivery of Earth observation data at no cost to support disaster management and humanitarian relief operations in areas of the world affected by natural or man-made disaster. This initiative involves 15 space agencies handling a constellation of 42 satellites, 33 Earth observation missions, and with different sensor type, optical, radar, altimetry, meteorology. In this framework, the Earth observation data received from the charter members is provided to the end user via a charter operational system managed by European Space Agency. It coordinates the delivery of maps from the value-added providers to the end user and cooperating bodies as appropriate. Since 2007, ESA has been involved to augment the system with an online processing environment to facilitate the access and the processing of big volumes of geodata provided by the charter members. And we at Terradue were selected by European Space Agency to design and operate a new online service to visualize the satellite acquisition at full resolution. And after almost a year of intensive development, a new portal named ESA Charter Mapper was officially open to support charter operations, and in particular, the product screening activities. Product screening requires the production of high-resolution RGB composites from acquisitions of all satellites of the constellation with many different metadata and data formats. This first challenge was tackled with the metadata harmonization for all missions. Fortunately, during the development phase, a promising common metadata language called STAC and dedicated to spatial-temporal assets was emerging, and we took the chance to use it extensively. Indeed, STAC provides the abstraction layer and reduces the geodata heterogeneity by defining a synthetic interface to data, highlighting the concept of assets, supporting cloud metatypes in single or multi-band enclosure, as you can see currently in this recorded demo of a disaster activation workspace. The Charter Mapper development contributed directly to new standards by providing useful extension to manage satellite characteristics, instrument specificities, processing lineage, or raster information. Behind the portal is deployed a cloud-native platform with several components integrating the latest state-of-the-art technology. Of course, it all starts with a spatial temporal asset catalog for indexing all the metadata of the acquisition. Then all the data is processed to cloud-optimized geosafe raster, allowing the Cocktail service to display various asset selections. And finally, all the components are deployed on a Kubernetes infrastructure to support the massive processing at scale. At this stage, the multi-mission product screening is the main use case of the Charter Mapper and thus require pre-processing of the satellite acquisition to have analysis-ready dataset to allow an homogeneous visualization and ready-to-process data of the different satellite imagery, and the usage of downstream and value-adding services such as change detection of fire. The current demo shows you a third-party service developed with partners at Terradue. We can see that the asset granularity and the COG visualization allows the project manager of the disaster activation to select efficiently the data to be processed. Typically here, a pre- and post-fire event acquisition to extract a fire change detection result delineating a burnt area in the region affected by the disaster. Basically, each remote sensing scene is calibrated to a common processing level. Optical dataset are transformed to top of atmosphere or surface reflectance values for each of the spectral bands, and SAR datasets are converted to sigma 0 backscatter value in all available polarization. Then a large portfolio of downstream services is provided to the users from those analysis-ready datasets. Flood mapping, hotspot, lava flow, and active fire detection, burned area delineation and intensity, pan sharpening, multi-sensor band composition, optical spectral indices, qualitative stacking, SAR amplitude change, or yet interferometry. This project demonstrates the maturity of the previously listed technologies to implement a comprehensive cloud-native platform with optimized data access and processing for an operational usage of satellite imagery. This is a fundamental basis for rapid response in the context of the disaster charter. Thank you for your attention and have a nice day. Bye-bye.
Well, thank you, Emmanuel, and comprehensive indeed. That's pretty impressive suite of capabilities within the platform there, and a pretty shiny presentation at the start too. I need to get a graphic designer helping me out.